Hello and welcome to our class today. So today we're going to be we're continuing our progress on weapons. Today we're going to be expanding what we looked at in the Tin Cup Alley project, and we'll be looking at a rocket launcher. Along the way, we're also going to talk a little bit about some camera details that will be important. Now, as we work today, there's some core ideas that I want you to remember from the past lectures. First is this idea of instantiating, and particularly being able to instantiate into a new variable that we've created. So for instance, when we were doing the Tin Cup Alley, we created a new variable called cloned ball that stored a rigid body, and then into that cloned ball variable, we immediately instantiated a ball at the location that the script was attached to with a 0, 0, 0 rotation. Now, we also looked last time at this idea of transform direction that converts local rotation into global rotation, so that what we can do is capture the local rotation of a particular object and use that to define the global direction that something moves. This was important because we used it using rigid body dot velocity. That the way the rigid body dot velocity did is you told it what vector 3 what direction it was going to use. So what we were using is the local vector 3 dot forward, converting that into a global direction and multiplying that by an amount to give it some forward momentum. Now, the last thing is we didn't talk a lot about it last time, but this time it'll be kind of important. We're going to use on collision enter, particularly for the rocket, so that when the rocket hits something, it's going to instantiate an explosion and destroy the rocket, so that when it hits things, there it goes. Now, these are all things that we've looked at before. The new things that we want to look at as we move forward in our objectives today is we're going to be creating a functioning rocket launcher. This will be done by making sure that we have smart rockets that are aware of when they hit something, and when they hit something, a script will determine when they explode. We're going to look at an idea called Frustum culling. This is not related to the rocket, but it's kind of a more general idea associated with our cameras that's still important for us to understand near and far clipping planes. This is something that works in Maya, in Unity, and Unreal. Any 3D package you use, Frustum culling becomes kind of an important one. And finally, we want to talk about the idea of temporary parenting. This will be really useful in the project that you're going to finally turn in, the Retro Rocket Runner, that allows us to temporarily or permanently make one object a parent of another. All right, so on the forums, you will have found 3 items to download. Those 3 items to download will include a Unity project that I've got opened here. Again, my layout might be a little bit different than yours. And then there'll be a rocket and a rocket launcher. Now, I'm using Unity 2019.3.4. If you're using 2019.2 point something, that's okay too. It should work fine. However, if you are using 2019.3, then when you open it up, you might find a few errors that pop up. These are just part of the standard assets that Unity hasn't updated. So if you just delete the 2 scripts that are associated with this, then usually that will take care of it. We don't need those scripts today anyway. What this scene has in it is it's got the standard assets in it because we're going to want to use things like the explosions and other things like that. But what it also is using is a bunch of the prefab, the prototyping projects that are kind of set inside of here. Basically, it just allows us kind of a playground to work with. Some of the things I do want you to notice is, for instance, these blocks that are set up have both box colliders and rigid bodies on them. What that means is, for instance, if we had all of these and then we went ahead, I'm going to turn off maximize on play, and played this, then we would see all of these kind of fall down into place. Now, the reason why this becomes important is later when I fire a rocket at it, I want those cubes to actually react to the velocity of the explosion that's created. Okay, so meanwhile, what I'm going to do is go and grab the other 2 downloads that are available. There's something called Retro Rocket and something called Rocket Launcher. I'm just going to drag those out into my scene. We want to do a few careful things with these just to get started. These are just downloaded objects. Now, as it comes in, I want to make sure that I do not generate colliders on this. We want to work with a much less expensive way of doing this. I'm going to make sure that there's no rig on it. There's no animation. In the materials, though, I do want to make sure that I extract the textures and materials. In this case, this only has materials, so I'll go ahead and extract that. I'm going to call into my folder called textures. This will allow me to adjust these textures later. And then finally, I'll do the same thing with the rocket launcher. Let's come into the model. Again, those should be fine. Make sure there's no rig. Shouldn't have to worry about the animation. And here, let's make sure I extract the textures into the textures folder. And then I'm going to extract the materials so that I can edit them as well. All right. So once all that stuff is in, what we should have is we can start to put things together. Now in the scene already, you should notice that there's a first-person controller. This is just a standard first-person controller out of the standard assets. But what we want to do is make it so that when I play the game, I can see my rocket launcher. Now as I bring that rocket launcher out, then it looks like it's not there. It actually is, but it's itty bitty, itty bitty tiny. Okay, this is pretty common, especially if you're working with different people working with different versions of 3D software. Somebody working with Maya, somebody working with 3ds Max, or whatever you're doing. What I'm going to do though is I'm just going to go ahead and drop this in as a child of my first-person character. Remember, first-person character is actually the camera. I hate that name. But that's what it is. And then I'm going to go ahead and zero all this stuff out for just a second so that we can see it. And then I'll take this rocket launcher. Let's make sure that that rocket launcher that we're looking at the pivot, I'm going to go ahead and scale that thing up. Where are you? Okay, so let's get that scaled up a little bit. Let's kind of slide it around so that we can see where this is. Let's make sure that it's not rotated in any other place. There's our camera. So what I'm going to do is kind of slide this out so that I can see it and start to scale this up so it's a reasonable size. Now there's a few things that are going to start to happen here that I hope you notice that are a little weird. Number one, as I start to put this thing into my scene, you're going to notice that there's kind of a weird thing happening here with the rocket. It's actually kind of cutting it off. Now the reason for this, I'm going to select both of them so that you can see what's happening, is that the camera right now is selected, and as I look at the camera, it's got something called a frustum. You can see that big shape that's happening here. Now, what we've got is this is where we're starting to talk about the idea of frustum culling. Now, this is what goes on. Let's let this represent a camera, and if we're looking at this from the top, and we can start to draw this frustum. Now this frustum, you can think of it as kind of the field of view. This is the things that are outside of this frustum. The camera doesn't worry about drawing. It only draws the things that are inside of there. Now, it makes sense on the things left and right. Of course, it doesn't draw those. But in order to keep things working swiftly, what most 3D engines do is they establish something called a far clipping plane. The far clipping plane means that it doesn't draw anything further than that clipping plane on this frustum. And it also has a near clipping plane, meaning that it doesn't draw anything closer than that plane to the camera. So for us, the problem is that we've come in and put a rocket launcher in there, and it means that this area is inside the frustum, but this area is outside of the frustum. It's closer to the camera than the near clipping plane. And so what happens is that the camera simply doesn't draw that part of the object. So the way that we're going to solve this is we're just going to slide that near clipping plane in so that it actually encapsulates that shape. So if we look at the camera here and we start to look at the options that are here, you'll see that here are the clipping planes with the near and far. So for instance, if I increase the near, then you can see it kind of disappearing, the amount of that rocket launcher that we see. Or if I bring it back closer to 0, then we can see that we can see all of what's happening there. So we can kind of get this adjusted to however we want it. You can kind of adjust it for your taste. Again, the scale here is not absolute. It doesn't really matter what that's set up as. Some of the things that we do want to make sure, though, that I want you to notice is that first of all, if I'm using pivot and local, that we can see that the rocket launcher's front is in the positive Z direction. Now, this was stuff that was fixed for you before you opened this, but we want to make sure that we have that. What this should do now is if we maximize this on play and I hit play, then as we move through the scene, then that rocket launcher will stay with us. All right, so you can see that it's a reasonable size. It doesn't clip through the floor, all of those kinds of things. Now you can do all sorts of other goofy things. So for instance, if we just want to hack this, and I'm just going to change this to metallic and much more smooth. I don't know why we would have a rocket launcher that was that glossy, but you can kind of fool around with these. This usually isn't how we would build this in a game engine, but if you want to fool around with that, then that's what we can do. All right, so the next thing that we want to do is start to build the rocket that this is actually going to throw out. Now, we're just kind of goofing around, so I've got this retro rocket that I can bring into the scene. Now, of course, this retro rocket is huge, it's the wrong size, and looks really goofy. You can change whatever you want on this. If you want to start to play with different colors, you're welcome to. It doesn't really matter. If you want to start to make this more metallic, if you want, you can do that. This stuff is all kind of nonsensical. It doesn't really matter what this stuff is, but if you want to kind of dial that in, then you can. Finally, I want to take this rocket and I'm going to scale it down so that it's a more reasonable size to be launched out of that RPG right there, which of course wouldn't launch out of this rocket, but it's just going to be fine for what we're doing here. Okay, so let's get that to be a reasonable size, and that should be all right. Now what I'm going to do is kind of slide this over here so I can start to play with it. What I want to do is eventually I'm going to kind of fire this rocket out of my rocket launcher, which will be great to work with, but I'm going to start to make some other things that make it look a little bit better. So for instance, I can come into standard assets, and in the particle systems, there's things like the afterburner. So I'll come and drag the afterburner as a child of that. You can see that that's, first of all, pushing the wrong direction. So I'm going to rotate that around 180 degrees. I'm also going to do some things that we've talked about before. Let's make sure that the scaling mode is set to, let's do hierarchy, because now I can do things like scale. Let's not do hierarchy. Let's do local, so that I can scale that as I need to. Let's go ahead and play that simulation. Maybe we'll scale that down a little bit so that I can start to have that look like I want to. All right, so the exact scale here doesn't matter, but I just want to get kind of a goofy kind of setup there. Now I could do other things like here, let's come and put a flare in here. That flare, let me go ahead and make sure that its position is 0, and then I'll slide that back to the back here. That's also kind of big. Let's change the scaling mode to local, and let's see, where's my mouse? And let's scale that down a little bit so that it's set into place. Now, if you start to have the smoke and sparks too big too, I'm going to go ahead and tell them to make theirs local as well, so that you can start to decrease the size of those sparks if you want them. Okay, so once we get that, we're just goofing around here. Let's duplicate that. Here, let's look at it from the back. And I'll put one of these here, one of them here. I'm just hitting Control D, and one of them up here at the top. So that should give us all these flares. Oh, it looks like I got my flares inside the... Let's slide them back out here a little bit. Let's make sure we get those 3 flares so that we can see them as well out on the ends there. So we've got those set up. Let's see, I've got one, must have a double somewhere. That one. Oh no, they're all there. Okay, just wasn't simulating. All right, so I'm kind of getting the look here. Now, one thing that I do want to make sure is to look at things like the afterburner. You'll see that it's got some other gizmos on it, and these gizmos are referencing other scripts that might be on it. So for instance, it's got a sphere collider and an actual physics script. We don't want to let this afterburner actually control the physics here. So what I'm going to do is I'm going to remove the component of both the sphere collider and the physics so that I can control what's happening. All right, so maybe I'm going to call this retro rocket, I'm going to call it retro rocket prefab so that I can make use of it as I go. Now, what I want to do here is one last thing before I make it a prefab is I'm going to be using the same tools that we did last time in that I'm going to instantiate the rocket and then give it velocity. So I want to make sure that this object has A, a collider, and B, a rigid body on it. So I'll come in, select the object. I'm going to add a box collider. It'll be among the cheapest of colliders that we can use. The default setting for that collider might be reasonable, which that's not too bad. I'm not going to worry about it rolling on the ground or anything like that because eventually it's going to explode as it goes. And then the last thing is let's make sure and add a rigid body to it that's set up. Okay, so now I've kind of got the parts. What I do want to make sure is that I've got this prefab as its own prefab. So let's make an original prefab over here, and then I can get rid of this one. What this will allow me to do is that I can instantiate this prefab when I'm ready. All right, so let's write a little bit of script. This will be pretty fast to get going here. So I'm going to call this my RPG script. With this RPG script, I'm going to start building this using techniques we've already talked about in class and kind of build up to make sure that all the different parts are working. So the first thing that I want to do is that when I press the fire button, I want this to launch that rocket. So let's come in the update, let's write our first bit of code and use if input dot get button down, and the button that we're going to use is fire 1. Now we talked about this last time. If you want some refresher on where that comes from, make sure you look at our last tutorial. And so right here, let's write a debug log that says pew pew, just so that we know that we're hearing that input. Okay, we can come back here. And now what I'm going to do is just to make this easy, we will change this in a minute, but I'm going to come over to the rocket launcher and I'll go ahead and add this RPG script to that rocket launcher. All right, so let's come and look at what's happening here. So if I start to play the game, then I can look around, and when I press the fire button, you can see pew pew happening down there in the console. If I don't maximize on play, then we'll see that every single time we press pew pew, then we're getting that to work. Okay, so in simplest forms, what we want to do is use stuff that we've used before. So I'm going to make a public rigid body here that I'm going to call rocket. Now down here, what I want to do is that when I press fire 1, I want it to instantiate that rocket and give it some velocity. So I'll create another variable called cloned rocket here, and then immediately into that cloned rocket variable, I'm going to instantiate the rocket at wherever this thing is at, transform.position, and I'll just use, well, okay, we'll just use quaternion.identity here. That should be fine for what we're doing. Okay, and then because we know this new cloned, since it's got a name, then we can come into cloned rocket and we can use our good old friend velocity. Velocity is going to be a vector 3. So what we can use is transform direction because we want to convert its local rotation into global rotation, and we'll use vector 3 dot forward. Now remember, we can use vector 3 dot forward because this rocket launcher, the positive z, is actually the forward direction. Vector 3 dot forward, and let's multiply that by, let's call it 10. We might come and change this as we go. All right, so if we come back to Unity, let this compile for a second. Then what will happen is our rocket launcher should be asking us who's the rocket. Okay, now what we want to use, of course, is the prefab because the prefab has a rigid body on it and we can drop it into there. All right, so what will happen now is that when we play the game, whenever we press fire, Okay, so I'll step back and I press fire, then you can see that instantiating that new rocket, kind of shoving it out as we go. Now there's several problems here that are going to be kind of important. Number one, I want you to kind of notice where this is actually firing from. Okay, it's actually firing from the center right there that's happening there. And two, there's this kind of strange thing that these things are firing out, uh, and it looks like they're firing out at the wrong rotation. See how they feel like they're firing out sideways? Okay, so we need to fix those two things. We're at 20 minutes, so we'll go ahead and pause to here, try and get to that point. All right, welcome back. Welcome to part two, and we'll continue on fixing this up. So one of the things that you'll notice right now is that sure enough, we can actually fire the rocket, and indeed, if we're looking forward, then it seems to be okay. But if we start looking at either of the sides and we fire, then you'll see that that rocket is actually, here we'll go down and take a look here, that the rockets are firing sideways. In fact, they're all firing looking the exact same direction. The reason for this is the way that we've currently built our code. The way that the code is currently built is that when we instantiate the new rocket, it's instantiated the position of the gun and using 000 in world space. Now this is how we've done it previously with things like balls, but here we want to make sure that the rotation of the rocket when it's instantiated actually matches the rotation of the gun. So here we'll use transform.rotation so that it matches the rotation of the gun when it instantiates. So if I save that and compile, then now when we press play and fire these rockets will shoot out and they'll always be facing the direction of the gun. Okay, so they don't end up going sideways. Now we still have this other kind of strange problem though, that as we look at the rocket launcher, let's focus on it here, that the rockets are launching from a strange place, kind of underneath, because we've told it that that's the location along from where it's going to actually instantiate. So what I'm going to do is adjust this a little bit, and I'm going to give us a spawn point. So to do this, I'll make an empty game object. I'm going to call this my rocket spawn point. The actual name of it doesn't matter. And I'm going to make that a child of the rocket launcher. I'm going to zero out its position to start with, and the scale B1 just to clean it up. But then I'm going to come and grab this spawn point and put it kind of right there on the tip of the rocket, of the actual RPG, so that the rockets will instantiate here and instead of down here. So I'll need to do a few things. One is let's come and remove the RPG script from there, and instead I'm going to add it to the spawn point. Again, I'll tie this back in the same way here, so that what will happen now is that when we play the game, it will instantiate. It'll kind of come into existence right out there at the front of the gun. Now the other thing I'm going to do is do a few quick changes with this prefab. If I double click it, I can edit it. This is fine. It's got the rigid body, but I'm going to turn off the gravity so that the thing just keeps on kind of shooting forever. So that now when I get ready to fire this, then these rockets will keep on firing away. And so what I'm doing now is this game will be my dance club designer. Because what happens is those rockets, as they fire, then they just hit a surface and then they just start spinning around. So what we need to do is make sure that we have those rockets so that when they hit something, then they explode. So to do this, we need to make these rockets smart rockets. So I'll create a new C# script that I'll call my rocket script. In that rocket script, we'll make use of the techniques that we've talked about before, specifically with on collision enter. So let's come in here, and we know that we'll need an explosion as we've used in the past. So let's make a variable to store the explosion, and then we'll use on collision enter. it automatically fills in the arguments that it needs. And what we'll do here is we'll say, look, when you hit something, what I want you to do is instantiate explosion at wherever I'm at, because this will be attached to the rocket. And then here we'll go ahead and use quaternion.identity so that the explosion is actually kind of rotated 0, 0, 0 in world space. And then I'll destroy whatever game object this script is attached to. Okay, so I'll save that. Let's come back over into Unity. We'll let that compile for a second. Then we need to make sure that rocket script is attached to the rocket prefab. So I can come down here. I can either add the component or I can just drag the rocket script down onto it. This will then need to know, oops, our explosion isn't public, so we can't plug that in. So let's make that public. We'll come back in. Once that compiles, then the script should be asking for what is the explosion you want me to use. So we, just for easy sake, let's come into the particle systems. We'll grab one of the prefabs and we'll just use the explosion in there. Now remember, the thing about the explosion, we've used this before, is that if you look at the explosion, it includes a force script. So it actually applies force to things around it. So what will happen is anytime that rocket, this rocket prefab, hits something, then what it'll do is it will instantiate that explosion, which has force on it, that will give force to anything with a rigid body around it. So if we take a look here, and here I'm going to make sure that we can see this just a little bit differently. So I'm looking over here. So that what happens is when I shoot that and it hits something, then you can see it actually firing stuff up, right? So anything that has rigid bodies, then we'll see this explosion start to happen. All right. So there's the basics of how that would work. We can start to kind of shoot these. You'll notice that, for instance, the explosion is leaving these lights behind that are happening there. We could write a really quick little script to allow us to automatically destroy the object if we'd like. In fact, here, let's do it real quick, and then we'll finish off this tutorial. So let's call this explosion destroyer. And then what we'll do is in this explosion destroyer, we'll just make an enumerator here. Well, or we'll just do, turns out that that destroy actually has in it a delay. So let's look at the API and make sure we understand how this works. So let's look at the scripting reference here, and let's look at destroy. So you can see that we could destroy the object with a float. That t is the optional amount of time to delay before destroying the object. So let's come in and we'll use it just like that. We'll say let's destroy. When you come into existence, let's destroy this game object, and let's wait for an arbitrary 1 second, and that should kind of clean itself up as it goes. Okay, so I just need to make sure that the explosion, oh, looks like I've got a syntax error. Oh, yeah. Okay, so we'll come back. Let's come into the particle systems. On that explosion, I'm going to go ahead and add a component here that, what did I call it? Explosion destroyer. So that what will happen is after 1 second, it should destroy anything that's left over. Let's just check and see if it works. Yep. So maybe 1 second is even too long. Or maybe it's too short. It'll be okay. We won't worry about it for now. All right, so there we've got our rocket launcher firing away as it goes. Okay, that'll be all for this tutorial. In the next chapter of this, we'll go ahead and look at how we would set up our next game for the Retro Rocket Runner.